What's up, everybody? Welcome to another episode of Archill Podcast. Today I'm joined with an amazing people, Zaal and Rafael Kalandadze. Zaal is a remarkable entrepreneur and tech enthusiast. His co-founded AI startup Pulsar AI not only achieved a successful exit on US market, but also stands out as the first Georgian startup with such a success story. On the other hand, Rafo is an exceptional machine learning engineer with years of experience. He's currently involved in data science master's degree. Besides learning, he's deeply engaged in scientific research, which brings unique expertise on the table. Currently, they are both working towards the same goal, to create the very first Georgian LLM. It may sound too ambitious, but they are having an amazing progress, which you will witness in the following conversation. So without further ado, here's my conversation with Zaal and Rafo. Enjoy. So my first question goes to Zaal. So people say that if you have done something already, it really helps to do it again. And how is it in entrepreneurship? I mean, I'm really curious, you have done it, right? Before you have successfully co-founded an AI startup before. And maybe can you share what are the things and learnings you think you will do right this time, and what are kind of experiences which kind of really will affect the decision process this time?
The applicability of the experiences, prior experiences, right? So what we've learned doing things in Georgia and then doing things in the US is that the most obvious thing to learn is not just how to solve the particular problem, but actually to learn how to work together as a team, to learn how to be a team, and as a team, how to be a problem-solving team. So, so that is what we learned is like crucial part of actually building the company, because the company is nothing but the team, right? So, and no matter the problem and the idea and the startup that the team is actually engaging in and solving the problem, it doesn't matter. Yeah, what matters is how the particular team, the people in that team, how they like to work each other, between each other or not, how they're having fun together, how just uh, you know how those particular groups of people interact with each other, and whether they like spending time with each other or not. And it's just that because after some time passes, and you, as a group, you of people, you spend time together. It's just a matter of how good you are at living together, like going through the stages in life together. And those stages in life, when it pertains to the startup, those stages are going very. Things change as the team kind of goes through uh, the stages of building the product, uh, realizing what is the product, realizing what is the problem that their customers, that they see as their customers, what they actually perceive about the product, and how that evolves, right? So that kind of spans through the years. And when we're talking about the core team, that core team needs to stick together. And maybe some other people who kind of join in the later stages, those people may be changing over time and everything, but the core team who actually builds the culture in the company, those core team members, they kind of dictate and set the stage for how and what is going on in the company, and what are the cultural values that the company kind of builds as a bonding tissue between each other. So that is something that doesn't matter where you are, or what you're building, or what is your product or the solution, whether you're like hardware startup or software startup, it doesn't matter. That part is like applicable to anyone building and doing anything as a group. So most valuable thing to do is that to build the team, build the company, and then no matter what you're doing, then you can do anything with this team. You can build anything. You can kind of solve any problem if the team sticks together. They like working each other. They kind of enjoy living together. Then then it's the just the matter of what is the culture, and whether that culture is kind of solution in the space of solutions for the particular problem at hand, whether that would be the problem that that team would be like against solving against or something. So that is what we've learned from our experience. Not particularly what the actual solution for the problem, because those problems, but that is kind of the more like a methodology of what tools and what setup you need to then actually solve any particular problem that you might be interested in solving in any future startups or future organizations. So that was the most valuable lesson, most valuable, just a scar tissue to actually build, and then build the confidence in anything that we kind of set set ourselves to solve something else. So yeah, I think most valuable lesson to learn and to kind of build the intuition in doing that is to assemble the team and set the value standards.
Okay, good. So
Okay.
the next question probably is like, and probably this term of AI startup has evolved, especially in these recent years. But what do we mean when we say AI startup? I mean, do we just mean a startup which kind of consumes an open AI API, or a startup which kind of builds its own some AIs, or what do we mean when we say AI startup? Can you tell us, Sal?
Oh, um, well, I don't know actually, but probably building and on top of AI, like different AIs, would mean that it's we can draw some analogies there. Does it mean that you're a software startup if you're building on top of other open source libraries or some kinds of frameworks? It still does, I guess, right? If you're using, I don't know, Stripe API or something else, it's still something that you build on top of and then provide some value to the customers. So if you're building something on top of OpenAI's APIs, you still you still use and you still deliver the the value to the customer that otherwise would not be probably would not be possible with the previous generation of software solutions, right? So whether you're building on top of other people's or doing your own is still maybe considered an AI startup. But we could draw some distinctions in terms of if you're doing things as a like fundamental building blocks of AI or building on top, then yeah, you could distinguish. But it doesn't matter actually. For the customer, it doesn't matter. For the investor, that might be something to look into and consider. But for the customer, it doesn't matter, right?
Okay, got it. And maybe let's talk a bit about the research part in AI, product development, or simply maybe this question to Rafa as well. Like, what part of your job consists of this R&D, and maybe first let's ask Zal in general in AI startups when they are building some core AI technologies, and maybe then Rafa could tell us what part of R&D, kind of personal R&D, is part of your life. Like, how often do you research some latest papers? How often do you dive on your own on those latest trends in science? So, can you tell us a bit?
Yeah. So still, it depends on the what kind of solutions are you looking into building, right? So if you're doing this core tech kind of work that you will provide some value to other developers who might be building on top of your work, then you're in different segment. You're not in the direct to customer segment. But if you're doing things on a ready-made kind of solution that you deliver to the customer, like ChatGPT or some other solutions like I don't know Grammarly or something, then you're in a different area. Or maybe you're doing both. You're doing your own research and core tech, and on top you're doing something that actually delivers value to the customer. So that's different areas of the market that you're looking into, and that also depends on the the experience of the team, how experienced they are in different areas, and how they're good at delivering the value into different segments of the market. But uh, if you're asking about us, we're very new and we're kind of figuring out what to do and how to deliver value the best way possible for the maximum value that could be generated by our work, and how that would be sustainable enough and durable enough for that to enable other developers, firstly us ourselves, to actually build a durable business out of this. So we're doing both right now, mostly research right now, but we're going to build on the applications on top as well.
Good. And Rafa, what about you? Like, how do you approach, like, personally, not at work, just this learning and exploring stuff of this latest tech, maybe, just
Um,
as an ML
yeah.
engineer, if you can share.
Mhm. So yeah, I think that's a pretty new problem because we have exponential growth in the number of daily papers. So for example, 10 years ago, we only have like 10 papers a day, and now we have tens or hundreds of thousands of papers. So it's almost impossible to read all of these papers. So we need to um, some kind of tools or something like this. So, for example, read some newsletters, follow some people who is publishing daily basis their ideas or like some summary of the papers. So, in my case, I spend like 1 or 2 hours a day to read latest papers, at least abstract or something like this, to know what is happening, and yeah, like this.
Okay, Got it. Thank you, guys. And now, like before we dive into what you are doing right now, let's talk a bit about AI and machine learning in general, kind of to get ready for all those topics what you're doing currently. And maybe you could tell us and tell me, who is not like very good at AI or machine learning, uh, what is machine learning actually? Like, to explain very simply, without any technical terms, and what is AI and how do these two terms relate? Is one subset of another, or what? What are they actually? Can you tell us?
Okay, so so maybe start with the last question. What is AI, and what is machine learning, and how they relate to each other? So AI is bigger. I mean, AI could be like, what I used to say is that you could build AI with just the regular good old programming if else statements, and you could do that for every parameter, every billion of parameter that is probably in the latest LLMs right now, right? And argue that all of those billions of parameters, yes, you could write if-else statements for them, and probably the ReLU or something, some other kind of activation is something like if statement at the end, right? Because it's something like it's a function, uh, like depending on some input, it will or will not output something that will be propagated uh, further. But just to say, what is AI? AI is a big field that contains many other fields, and AI is just the method and create more and more human-like functions and behave more and more like a human would be behaving in certain circumstances, like deciding more and more on the decisions that intelligent human being would be engaged in deciding what to do based on the more and more complex situations that is maybe we're facing in our lives. But that is AI, right? So that is something that used to be not possible, and now it's possible with smarter machines. But one way to achieve that, and machine learning in itself contains some other disciplines like deep learning, or what they call traditional machine learning, and the deep learning is our bread and butter right now. And what every other uh, intelligent system is behaving, that's because it's built on the deep learning foundation. And what deep learning is that it just learns from the examples, just like we do. So that is just a like simple distinction. Like AI is very big field, and it contains many other fields. It could be achieved just like by traditional programming, but it's just impossible because no single or person or like groups of people would be able to code all the logical conditions by hand, um, to build such a complex and such an intelligent system. So the solution to that problem came from the analogy of the how human brain works, and how human brain works, and not only human brain, but any other like creature on Earth who has the brain and who actually lives by the laws of not only the sensory, any creature who has sensory inputs and decides and moves and decides what to do based on those sensory information, those are somewhat on the spectrum of intelligence, and most intelligent most intelligent creatures are tend to be those who are closer to us in the evolutional development. And yeah, so the analogy is how brain works, how those synapses and those cells communicate between each other and propagate information between each other, and eventually reach the different parts of our body to actually um react to the sensory inputs. So um, yeah, it's just the method of replicating how the nature actually did what it did, and how we function as the most intelligent beings on Earth. And that is just a rough, uh, rough kind of analogy that we're doing right now, building those artificial neural networks inside of the computer system. And that is not very efficient, and people are working towards enabling more efficient ways to compute those billions and billions of parameters, and how to add those up, and how to activate those artificial sorry
No
neural
problem.
circuits more efficiently, because our brain is very, very efficient in all of those very smart things. And what we're doing right now, uh, running those computer systems on the GPU systems, those are not very efficient. Those are very power hungry. And that is a major challenge to actually uh, solve, to not consume so many resources that those intelligent systems need to run.
Okay, got it. So the next question can be to Rafo. Rafo, can you tell us maybe? So I very often I hear these terms like model and model training. Okay, and can you tell us what is actually meant by that? I mean, what do we mean by machine learning model, and what do we mean by training that machine learning model? Actually,
Um, okay, actually, that's not an easy question because you can explain the model concept in a bunch of different ways, but I'll try to explain it like easily. So the model is kind of a structure. Um, okay, let's say I'll give you an example. So we can compare the model as a person, let's say, for example, as a student who can learn some kind of new stuff. And you just need to give it some resources. It can be a books or some videos, some like YouTube videos, or maybe audio as well. And uh, also you give it the goal. For example, you're saying that the student should be able to pass the exam, for example, math exam or other kind of stuff. So how this person will learn this new stuff, you don't care. You just give it the data and the goal, what you want to achieve, and that's all. All the other stuff is on the student itself. So in this example, the model is the student, which is kind of a structure or a bunch of functions, let's say, more technical way. And the model training is just the time, the process when the student tries to learn, tries to read the book from top to bottom, like watch the videos and all these processes, like all this bachelor degree is just a model training. Um, and yeah, based on this iteration, based on these homeworks, these exams, um, uh, yeah, the person tries to learn more easily, and yeah, that's the training loop actually. I don't know if it's a good example, but uh, I'm just trying to tell you.
Yeah, that's a good example actually.
Yeah,
Kind of real life example. That's good. Okay, good.
yeah.
And now let me switch to a more niche, kind of niche field which you are operating at, guys. And what about these LLMs? And as far as I know, LLM stands for this large language model. And the first question which comes to my mind, are there other language models like small language models, or it's just large because it's just large and they just called it? Can you tell us, like, what are they, guys? Like, what are LLMs actually? And if there are some others like small SLMs, maybe you could tell us about them as well.
Okay, so large language model is a like specific example of the models of the student that we discussed. So the which works on the text basically, and it can analyze, extract some information from the human language. But under the hood, it's a quite simple thing. It's just a model which predicts the next word based on the text that you give it. So let's say if I give you the subset of the text, and if you're able to predict the next word, which is like the correct continuation of the previous text, then you are a language model. So uh, that's just the idea of how it works and what this model are doing. But it turned out that it's a quite powerful technique because the generate next word means that you should be able to understand, like you should have the word knowledge. So let's say if I give you the text like Albert Einstein was born, and then you should generate the next word. It should be the date or something like this, right? So you should know uh, when he was born or something like this. So it means that if you can generate the next word correctly, it means that you have quite powerful knowledge in yourself. So that's how it works actually. And what about the small language model? Yeah, that's a good question because that's what we are working on right now. And yeah, actually, the first term was large language model because several years ago, OpenAI team found out that if you increase the model size or increase the data size, yeah, you can have better performance. It's like a straightforward way how you can have the better models. So they just trying
Scale.
to increase. Yeah. So they know the formula of better performance. So they tried to increase the model size and data size. That's why we got the large language models. But now people think that maybe it's not necessary to have these kind of huge models because it take like um, some kind of resources. So you need hundreds of times training, or you need vast amount of data, which is maybe time consuming, or it's not necessary at all. So yeah, then we have a small language model, which is like a smaller size, and the data is relatively small as well. And but you change the data quality. So if you have better quality data, maybe you can have better performance, and you don't need to have whole internet um, data in your model. So that's the idea. And for example, last year, this community is mostly working on small language models, and yeah, and that's what we're working on.
Yeah, not much to add actually. But nowadays, like multimodal language models are also kind of becoming popular, and those are enabled not only by language but also by being able to extract information and communicate in a visual or auditory in auditory ways. But in the core of those, all of those are still the language, because one of our most significant discoveries or technologies that we as a humans developed is actually the language, which then enabled us to communicate much more effectively, much more easily, and to write the experiences and the knowledge that we've gained throughout our lives on paper, and then enable future generations to learn from our experiences, not only by telling stories like fireside storytelling, but also be able to durably store the information about all of the civilization's achievements, and then build on top of that throughout the generations. And that that is the language, right? So the method to put the knowledge and experiences in writing, and that is what was predominantly uh, our domain of expertise. Like, we were creating the knowledge and then putting that into paper. But now these large language models enabled not only the so the previous technologies enabled just the distribution part of language, but this new technology, those LLMs, are enabling us to create more knowledge, uh, still by our instruction, but they are actually enabling us to distribute and scale up the knowledge, distribute knowledge creation, and then the distribution channels are all the same. So that is very something that fundamentally is different from the previous technologies, because it enables new knowledge creation apart from the previous technologies like internet and general computing. And that is very, very interesting and different from the previous technologies, as I said. Now, other than that, it's fairly simple, as Rafa mentioned. Simple as in, if you're able to look at the enough information prior to predicting the new one. If you're able to look at the previous tokens of the sequence, and that's one, like how far in the history you're able to look, as like measurement of your capacity to do that. And the other thing is how effectively and how precisely you're able to relate different things mentioned in those sequences between each other. And those two things in combination, like those language models during the training and then during inference, those language models are more and more capable of doing farther and further behind, and able to relate those different parts of those sequences together to come up with the next word that should come after those, all of the things that have been mentioned before. So as a simple example, consider like just a book like detective or something, and consider the example that so this book leads all the way up to the end of the book where this the investigator should reveal who's the murderer or someone. And
Yeah.
if you're able to look, so if you have to consider everything this detective is considering in itself, and concluding through his thinking who should be, who must be a murderer. But if you're unable to do that as a human in the beginning of the book, on the or in the middle of the book, and it must be everything considered in that book to for you to be able to uh, like say with a very high probability, say just one name who was the murderer, then it's the same thing, right? So that is what the language model does. Considers every fact that has been mentioned in the book, considers every world knowledge that it has, and this causal effects of certain uh, events that has been mentioned also in the book. So everything has to be considered to for the person to be able to with a say with a very high certainty that this particular person in the book was the murderer. So that is something that actually happens. Something like that happens when the language model is being able to uh, predict the next word, and that is a very significant achievement, I think, because
Yeah.
in this process, this is the task is very simple, but in this process, to actually this model to be actually able to do that, it has to learn so much more, so many things about the world that is like projected in the text that it has been trained on. Is that just it learns so many skills that it's very relevant to our being, to our, and that's why they are very useful.
Okay. Thanks for this detailed description and overview. And maybe next question would be like in software engineering, we have this kind of go-to interview question for beginners. It's like what happens when you type Google in browser and hit enter. And can you walk me through the process? What happens when I type a message in ChatGPT and press enter? Obviously, ignore this API software engineering parts. So, how does this message propagate in all this AI model or some core or brain, which kind of uh, responds with a meaningful answer to my message?
Okay, maybe I'll start and then Dal you can add.
Yep.
Okay, so first, ChatGPT tries to detect what kind of um, tools does it need to use. So, for example, if you give it some question that requires some internet connection, or you maybe ask to generate the code or maybe generate the image, first it tries to identify what kind of information do you want, and it's like if you want to generate the code, it will pass this question or this prompt to the like other model that it has. Like this is a bunch of different models, so maybe it needs some Python
Yeah, yeah, got
console
it.
or
Yep.
some interpreters or maybe an internet browser. So it first detects tools and then use those tools to get more information, generate some text, and after it concatenated all this extra and metadata information, then it tries to analyze text, extract some information, and give it to you like more human way and the way that you wanted to ask. And that's the main idea. Also, there are some pre-processing and some other more technical stuff, but the main idea is, yeah, that's all I think.
Okay, let me come up with a follow up question. So let's say this brain of AI of any LLM or whatever, let's say ChatGPT, is just a big
Mm-hmm.
house, and now my message is delivered to the door of this house, and
Mm-hmm.
like a person took this message, kind of received it, and what happens in that brain? I mean, uh, if of course we can explain it in easy way. I mean, does it propagate in some kind of network, like in brain, in this kind of neurons, or how does it kind of consume this message? Actually, like how does that process
Mm-hmm.
happen?
Yeah, so when it takes your message, it propagates the whole network, and let's say the model predicts that this information to answer this information, I need let's say Python interpreter or something like this. So it
let's
tries to
let's let's
ask.
ignore Python interpreter. More simple. Let's
Okay.
say more simple task. I mean, let's say I ask ChatGPT to solve some equation. Very simple math.
Mm-hmm.
Okay, let's stick with that
Yeah, so
without Python.
first it generates the solution, some kind of formulas or I don't know, and then it tries to. It also has a calculator in it, so it tries to type all these formulas or these numbers in the calculator and analyze this equation and just confirm that these formulas and this answer is correct. And then if it's correct, then it gives you the answer or something like this. But if you ask some kind of question that doesn't need any extra information or any extra models, then it just goes through the model, generates actually the knowledge that ChatGPT has. That's maybe it was already in the train data or some similar data was in the train. So yeah, it just generates the answer and gives you the output of the model. That's all I think. I don't know how to answer it without technical details, but
Okay.
yeah.
Yeah, it's kind of difficult to answer that question. So the question was how whenever some request comes into the network, how what actually happens in the network, right?
Yeah, yeah, that was the question.
So probably that's just just the math, the linear kind of algebra that happens in there. It's all. Oh, if you ask the guys who developed this sophisticated GPUs that actually enable those neural networks to operate much faster than the CPUs would be able to, then they will say to you that those hardware chips, those are specially made to actually operate in parallel on many numbers and to add and multiply those numbers concurrently very fast. So that is actually what's happening there. But on an abstract level, what's happening there, no one actually has an idea how what is actually happening there. Because that's why people actually say that it's not something that we built, but it's something that we discovered. It's not engineered. It is engineered, but in part, it is something that we discovered. Uh, what's what abstract things are happening there? It's very very hard to analyze. Uh, so it's also very hard to analyze what's happening in our brains, but that is more difficult to analyze because that's not a digital object. It's a biological object that is much harder to analyze. I think Raphael would be able to dive into that much more deeply because he actually does related things to like scanning the activity of the brain and stuff. So that is something that it's very difficult to analyze because many small units are involved in different combinations, and that is actually why referring to the previous conversation about what is AI and what is machine learning, what is deep learning. That is why this the whole area became a thing, right? Because it was not effective to code everything by all of the variables or all of the different things that would be considered in building some more and more complex systems.
Okay, so now, guys, the kind of sweet topic which I want to talk about with you is what are you doing right now? So Zal, can you tell us what is this thing you are kind of researching, developing, or doing, and just tell us everything about it if you can.
Well, it's very exciting. Yeah,
Yeah,
what we're doing right now, we're figuring out how to do Georgian language LLMs, and potentially not only Georgian but other low resource language LLMs as well. And we're on a very good track. I think we started in like four months ago, and we're already at the end of this year, and we had a goal to actually demo something Georgian LLM-ish that would be able to operate somewhat similarly as ChatGPT, and we did that. We demoed that solution like a couple of days ago, and that is very promising. We learned so much during those 4 months. We learned and we gained a confidence in that what we're doing is very correct. We're on a very good track, and this is something that leads us to much bigger surprises, I think, than we ever imagined that would be possible. And we're just exploring this area, and we're also thinking about possible applications, not only the general assistant-like application like a ChatGPT that is very obvious, but we actually started in the vision of doing just that. And we're saying that as a nation, as a like the owners of this language that is very unique in the world, and we care about it too much to not to create this kind of technology that is rooted and based in the language. So we must have something of our own in that domain, in that technology, and uh, we're doing this research for now. But what we're hoping, and we have very good observation, very good evidence to suggest to ourselves and to everyone is that this works. This will work in larger and more sophisticated domains. Right now, it works on small texts, very simple texts, but it's able to demonstrate all of the capabilities that language models are able to demonstrate in larger areas. But this is very good model to encourage more research, more development, and more kind of activity in that area. So we're very proud and very excited for what it's promising to deliver in the nearest future, and we're we're kind of excited to work more on this because it actually confirmed all of the things that we were thinking and we were hoping. Like there were like things that we were thinking that like it must work, right? But there were things that also were in the domain of wishful, like hopeful thinking. But those things also has been confirmed with this experiment, and that is something that kind of blows our minds and encourages us to work much more on this and add some and new skills and new data sets and think about what's to come next. So yeah, that is something that we think that will change our lives and will change the course of the technological development in Georgian language, of course, largely speaking in the whole world. But for us, what we're doing, what we're hoping to achieve is that to actually play a role in developing and uh, getting like taking this language and getting it into the new technological realm and the level that is generative AI. So, so yeah, that's about
Good.
it.
I'm super excited about you guys, and I really see this passion and excitement you have. And can I just ask a specific question? I mean, you mentioned this demo, right? And you mentioned that it kind of met or overcame your expectations. But what actually does it right now? I mean, do you talk with it with some specific Georgian texts and it responds back with meaningful answers, or what does it actually do right now?
Yeah, I think Rafo actually did the demo,
Yeah.
and maybe he's the best person to talk about that.
Yeah, Rafa, can you share it with us?
Uh, uh, yeah, okay. So at this time, this model can generate some
Can you
short
share your desktop,
stories that
Rafo,
can.
to do the demo one more time?
Yeah. Okay. Okay, I'll try just a few seconds.
And not to interrupt our conversation, I'll put the demo in the end of the video so that you can witness those outstanding results of the first Georgian LLM. So you mentioned that you're kind of working now with this Georgian language model, right? And Georgian language is very niche language, very small language, and very specific, I would say. Uh, what are the kind of main technical challenges? Like the first question I have is where do you get the data from, the enough data to kind of create this model? So is that a challenge to you, or are there any other challenges in creating a language model for these small languages like Georgian? Maybe technically you can speak, Rafo. What are some things happening in this field direction?
Yeah, so as you mentioned, the main challenge, the main problem is the size of the data that we have in Georgian language. We have some open source data, but maybe only a few of them can be used to train the language model. So as you mentioned, we need a vast amount of data for LLMs or SLMs. So in this case, that can be a challenge, but in the last few months, there was some research, some papers who found out that you can generate some synthetic data based on these large models, based on these teacher models, I would say, for example, ChatGPT. So yeah, we know that we can generate the data in English, but what about Georgian? So it's still a problem, and yeah, we have to train our another model, machine translation model, which translates the English into the Georgian. We already have the Google Translate, but it's not a best model at this time. So for this domain that I mentioned, for these small stories that we are using, our translation model works much better than this Google Translate. So yeah, we spend 2 or 3 months to train and create this new model that helps us to translate this synthetic data into Georgian. And yeah, after that we have some amount of data for the training. That was one challenge, and also based on that, we don't have any other models in Georgia. Like that's the first language model, I would say. So we can't compare our results. We don't have any benchmarks, any data set that we can test or to compare our progress. So that can be another challenge at this time. But yeah, main challenge was the size of the data set. But I think now we have some kind of recipe how we can collect more and more data if we need.
Yeah. Okay. Now, maybe my next question is to Zal. So you mentioned these other language models as well, like small language models that potentially, like if you do it in Georgian, you'll be able to do it in other languages as well. But how are they doing right now? I mean, are there like any examples of already kind of established language models created for such small languages out there, or it's kind of still you're kind of doing some pretty new thing with Georgian as well?
I think we're doing very, very frontier things right now because not many people are doing that. Considering that, just yesterday, Indian, like prominent Indian guy who's working in this area, they published this Tamil Lama paper uh, in which they demonstrate that they've been able to fine tune or train or adapt Llama model to Indian Tamil language. And considering how large India is and how many people live there, so uh, still the people who actually know how to work in this area, those people mainly work in large cities in the Western world, in America and Europe, and those people are already either working in the academia or in large corporations. So those people who maybe want to work on those local languages, they don't actually have enough time to dedicate their time doing that. So for us being concerned with Georgian language and creating Georgian LLM, that is very unique. No other group in the world is trying to do that. And so that's one thing. But for us, it's not only just Georgian language. It's just the research around the many things concerning how the language model, especially large language models, uh, behave and how they structure their knowledge in all of those connections that they have. So other things that we're interested in parallel of developing Georgian language LLM is that those areas. One area is how to actually make the model store the knowledge in one way and retrieve and communicate that knowledge in other ways, like in other languages. Just like we do, right? Or we have all of the thoughts stored in our connections in our native language, but then if we just learn the other language, like for example English, We don't just go through all of those memories and translate those and store those in the different language, right? We somehow are able to translate those thoughts in other language and communicate that on the fly, just like we're doing that right now. None of us are native language English speakers, right? So that is another area. And basically, if someone is just able to do anything concerning LLMs, it's just an opportunity to explore the adjacent areas and be able to discover many new things, because this is considered a very new area, just like personal computing, just like computers were like 50 years ago or something. And then it's just those computers evolved in being like big chunky, like bulky things, very not mobile, and sitting in the large rooms and like those punch cards or some other things. And then it kind of evolved in a more uh, modular and mobile thing that was with ports and connections, networking, graphics, all of those things that now is considered very natural thing for the computer to have. So we think that the same thing is going on in LLMs. It's kind of new paradigm of computing, and it will require much more things around it than we have right now. And that is something that we're excited to be part of. And along the way, if we're able to build things in our language, in Georgian, and contribute to Georgian and build the business around that as well, that's only a very a good place to be and good area to work in. So we're looking forward to discover more and potentially build businesses around that, not only in Georgia but also internationally as well.
Great, great. And let me get to the final question of today's conversation. So you mentioned everything like what you have now, what you have already kind of accomplished throughout these months, but what's next? So what are your plans like in near future? So are you, obviously you continue this research, maybe you think of some product development based on these discoveries and research you do. So what's next?
Um, we don't know really. So what I was saying is that we're in the process of discovering things that could be lucrative to pursue as either as a research area or a business area. So we're in the constant flux. What we see, what we're pursuing right now, is to build more skills, acquire more data, and be able to, uh, you know, experiment and do the this full cycle of experimentation and feedback, and then decision making, then like designing better experiments, and those that feedback loop is kind of bounded by the compute and the data. So those are two things that we're working right now towards. Like easier for us right now is to acquire like synthetic data and build the smaller translation models to usually get that data and get the data translated in Georgian, like a high quality, in a high quality way that is not accessible elsewhere right now. I think Rafa mentioned about Google Translate and how it's not very good in Georgian. So that is one direction that we right now we're most productive in. But hopefully we're going to be able to attract partnerships and attract outside funding whenever we're able to demonstrate like a concrete product and kind of potential, like product demo or something. So what we demoed, that was like a technology preview, and that was the demonstration of, okay, this thing actually works. We proved it that works. It works, and we are confident that it will work better in the future as we scale it up. But that was not a product, right? That was a demonstration of capabilities. Right now, what we're going to do in the future is we're going to come up with a product and demonstrate that product to the potential clients, and then build the product. So um, that is the plan. So what specific product we don't know yet, or what specifics of the specific product that will like be more apparent in the coming weeks, or like next month, end of month, or something like that. But we're not stopping. We have things to do before that, so we're busy doing that.
Yeah, I just want to add a few things. So, yeah, as Al mentioned, at this time we have the model. We just confirmed that we can create the Georgian language model, even though this size is quite small. It can generate like almost perfect grammar, like fluent Georgian text, and it also has some basic word knowledge and so on. So maybe the next steps would be to scale up this model and also use it in some specific projects or some company. And yeah, that's what I wanted to add.
Great. Thank you once again. I had just blast talking to you about all these interesting things. Wish you nothing but luck and all the best and all the success in this endeavor. So thanks again, and yeah, hope to catch up with you guys later as well and discuss some progress you will make. You will definitely make in next months.
Thank you, Archil,
Yeah,
for inviting
thank
us.
you. Thanks for inviting. And
So let me show you the model that we have right now. Basically, it can generate the short stories, which only use like simple words that a 3 or 5 year old child would like to understand. In general, when you want to test the model, especially LLMs, language models, you have some criteria. For example, the text, is this text written correctly? Also, you need to check the grammar. You need to check also the consistency. So the model should generate a consistent story, and don't forget the early history of the story itself. The factual knowledge is important. It should know some basic word knowledge. Creativity is important because you should check that model should not memorize the stories that we had in the train set, and the reasoning is quite important as well. Now I want to show you several examples, and then we can see that even though the model size is quite small and the size of the data set as well, it still managed to learn some stuff. First, let me type the prompt and then I'll try to translate it. Okay, so the prompt is about the turtle. So we ask the model to generate the story about the turtle who doesn't know how to run fast, right? Because we say that turtle tries to learn how to run. So it means that turtle doesn't know how to run fast, right? So the first thing that we can see is that the model took into account everything that we asked. So we have the turtle named Team. The turtle tries to learn. It had a friend, a rabbit. And also Team tries like every day to learn, and finally it managed to at least tries to run fast. Also, we can see that the story is quite coherent and fluent, I think. The grammar is almost perfect. And also we have the moral of the story at the end, which I think is quite hard for the model to generate like one sentence that sum up everything from the story, and also like generalize this knowledge and give us some like moral, like don't be afraid to try new things and always believe in yourself, which is quite hard to express all the main idea of the story, right? The main idea is to try new things, and the model managed to detect the core concept of the story, which is quite hard, I think. Okay, so now I want to show you something more. So after we finished the story generation part, then we thought that maybe we can add something more, like kind of a chat, so user can ask some questions and get some answers based on the generated story. So maybe we can have some tiny chat system. So we fine-tune the model on question answering dataset. So now you can ask some questions. Okay, let me first generate the story, and then we can ask some questions based on that. Okay, so this prompt is like tell me a story about a boy who lives in a castle, and he fall in love with a girl, and they live like happily after that. Okay, let's see the generated story, and now we can ask some questions. For example, okay, so where did the king and queen live? Yeah, they lived in the castle. Or maybe what the name of the boy? Yeah, the name of the boy is a Team. That's the truth. Okay, what else? Also, we can see the summary. Yeah, that's actually the summary of the story. Yeah, so as you can see now, we can have we have the model which generates quite good story, I think, quite fluent, the grammar, all the creativity, all the reasoning, like coherent story as well. And then we can ask some like maybe simple but some important questions based on the story, and it can answer on all of that. Yeah, I think that's quite amazing that we already have this kind of model, so we can now we can add some more data, increase the model size. So as I mentioned, the model size is quite small, but anyway, the main idea is that based on these short stories, still the model can generate and talk with people somehow. That's the main idea. Yeah.